My name is Erin Gallagher, and I'm going to talk about how urine is formed in the body. On this poster, I've drawn a nephron on the left, which is a urine producer, and a kidney on the right in order to describe how it is formed. First, blood enters the kidneys through a series of arteries starting at the renal artery, shown in red on the kidney, and it continues to the segmental, interlobar, arcuate, and interlobular arteries and enters the afferent arteriole, which then brings blood to the glomerulus. Blood will leave the glomerulus through the efferent arteriole. The afferent arteriole is shown with an A, and the efferent is shown with an E. The glomerulus is a site of filtration. Blood cells stay in the glomerular capillaries, which are capillaries that have holes in their walls, but other small particles will filter out into the capsule, which is a shell surrounding the capillaries, where now the substance is called filtrate. Filtration is not a super selective process because it's based only on what can fit through the holes in the capillaries. So while waste fit through, so do things like glucose and ions. Because of this, filtrate is not urine yet because it has too much water and other good things in it. The glomerulus is the capsule, and capsule together are called the corpuscle. This filtrate then goes to the PCT, the proximal convoluted tubule, where most of reabsorption takes place, about 65%. And a lot of those beneficial good things like glucose and ions are returned to the blood. The PCT has twists so that it has more surface area for more reabsorption to take place, and has a lot of mitochondria because ATP is used a lot for the reabsorption processes because things must be actively pumped out to be reabsorbed back into the blood. From the PCT, urine goes down the nephron loop, also called the loop of Henle. At this point, filtrate has become more like urine, and the nephron loop is where a lot of water conservation takes place, and water is returned to the blood so that urine becomes more concentrated and so that we don't get dehydrated. Some secretion then happens in the nephron loop so that waste that were not removed before entering the urine are now removed. But most secretion happens in the DCT, discussed further in a minute. Most nephrons are called cortical nephrons, which means the majority of them are in the cortex, but I drew a juxtamedullary nephron, which is a nephron that has an extension that goes deep down into the medulla, because a juxtamedullary nephron has vasa recta, while the other does not. Vasa recta help to maintain proper water balance. While I'm talking about vasa recta, I'll point out the peritubular capillaries, which are very important because they reabsorb nutrients like sugar, and these capillaries pump these things back into the blood. These surround the PCT because that's where reabsorption takes place. The urine goes into the DCT, the distal convoluted tubule, where secretion takes place and the urine may receive more waste. The DCT and the collecting duct can be controlled by hormones in order to maintain proper water balance in the body. Then urine will be dumped in a collecting duct that multiple nephrons feed into. After the collecting duct, urine is officially out of the nephron and moves into the renal medulla pyramids, where it goes into the papillary duct that leads into a cavity called the minor calyx. Minor calyx then merge to form a major calyx, which then merge to form the renal pelvis, which leads to a tube called the ureter. The ureter travels through the abdomen into the urinary bladder, where it is held until it is stretched and urine is pushed through the urethra and out of the body. So to summarize about the steps of urine formation shown in the bottom here, filtration takes place in the glomerulus, where substances move through small pores in the glomerular capillaries into the capsule. Most reabsorption takes place in the PCT and uses ATP because it needs to be actively transported out and reabsorbed using pumps. Peritubular capillaries receive these reabsorbed nutrients and water. The nephron loop of Henle, is responsible for water conservation, although some secretion does happen here. The DCT has receptors for hormones that help it control salt and water balance in the body, and also is a site of further secretion, so more waste that didn't filter at the glomerulus can be secreted.